Hello everybody, I'm just going to talk you through the biochemical tests for carbohydrates and proteins that you need to know for AS3. So the first thing to point out is these tests are qualitative, and what that means is they just show if something is present or absent. They don't indicate how much, or they don't tell us exactly how much of a substance is present. A test that would show that would be a quantitative test. So the first test I'm going to talk about is the reducing sugar test. This tests for all monosaccharides and maltose because all of these are reducing sugars. And remember your monosaccharides. You'll have done AS1, so your monosaccharides is your glucose, galactose, fructose. You know a lot of monosaccharides, but maltose, which is a disaccharide, is also a reducing sugar. So the reagent that you use is Benedict's solution, and every time you think of Benedict's, please remember that you heat. So you have to heat it. So if you were asked in your practical exam to describe the method that you would use, you add an equal volume of Benedict's solution to the test solution. So for example, add 3 cubic centimetres of Benedict's solution to the mystery, 3 cubic centimetres of the mystery solution. And you then pop the boiling tube into a water bath, and the water bath should be at 80 degrees C. A few years ago they started to mark people down who said you boil it in a water bath. You have to heat it in a water bath at 80 degrees C. Remember the safety precautions that you should take. You should wear safety goggles. So what would a positive test look like? Well, the blue Benedict's will become a brick red precipitate. Again, if you don't use the word precipitate, you will not get the mark. So the Benedict's test is a little bit unusual because although it doesn't tell us the quantity of sugar, it indicates slightly how much sugar is present. So if, for example, the Benedict's changed from blue to green, that would mean a very, very small amount of a reducing sugar was present. If it went from blue to yellow, that would mean there's slightly more reducing sugar present, etc. So that is the Benedict's test. So the next test I'm going to talk about then is the non-reducing sugar test. Now the most common non-reducing sugar that you will hear about is sucrose. Now if you carry out the Benedict's test on sucrose, the Benedict's will remain blue. But sucrose is a disaccharide. It is made up of glucose and fructose. So if the sucrose is hydrolyzed, it turns into glucose and fructose. And if you then add Benedict's and heat, you will get a brick red precipitate. So imagine you have a solution that you think is sugar, and you carry out the Benedict's test on a bit of this test solution, and it is negative. It still might be sugar. But what you have to do is you need to hydrolyze it. Now, in this case, when the sucrose is hydrolyzed, it breaks down into glucose and fructose. So you need to be able to describe how you would hydrolyze sucrose. So you hydrolyze sucrose by heating it in a boiling tube with dilute hydrochloric acid in a water bath. It's very important that you say dilute hydrochloric acid because concentrated hydrochloric acid you would not heat in a water bath. That would be very dangerous. Remember to say also that you would wear safety goggles. So when you heat sucrose with dilute hydrochloric acid in a water bath, it breaks down into glucose and fructose. But after you've done that, the solution will be really acidic, and that would mess with the Benedict's test. So you need to neutralize that solution. So you add sodium hydrogen carbonate in small amounts, and you keep testing the pH with pH paper until it is 7. After you've done that, you'll then have a solution, which hopefully is hydrolyzed sugar, and you'll then carry out the Benedict's test. Now, if it was a non-reducing sugar, your result will be that the Benedict's, after the solution has been hydrolyzed, will change from blue to a brick red precipitate. Now, the next test I want to talk about then is the clinistics strip test. Now, if you have a reducing sugar, it might be glucose, and there is a test that will prove that the reducing sugar you have is glucose, and this is the clinistic strip test. So you have a little strip, and at the bottom of it you've got a little pink pad. This is very quick and it's very accurate as well. So what is the method? You simply dip the clinistic strip with the little pad at the bottom into the test solution, and the test solution might, for example, be urine, and a positive result will be a colour change where the pink will turn purple. And the deeper the purple change, the more glucose is actually present. So that is the clinistics test. The next test I want to talk about then is the starch test, which you all know. So starch is a polysaccharide, and the reagent that you use to test for it is iodine. Now remember, see, I want you to say that iodine is yellow-brown. So what is the method? You have your test solution, you just need to add a few drops of iodine, and if the test solution does contain starch, the iodine will change from yellow-brown to blue-black. And then the last test that I'm going to talk about is the protein test. The reagent that tests for protein is blue biuret, and blue biuret actually tests for peptide bonds. It detects peptide bonds, which are obviously inside proteins. So how do you carry out the biuret test? We usually give you blue biuret, but say I want you to know how to make up biuret. So you add equal volumes of potassium hydroxide and dilute copper sulfate, and you give it a shake. So you've got potassium hydroxide, dilute copper sulfate, and then you would add your test solution and give it a shake. And if the blue biuret turns lilac, then you know that peptide bonds and therefore proteins are present. So what you should do now is look up your past papers and your mark schemes, and can you find every single question to do with biochemical tests? Read the question, see if you can answer it, and then go to the mark schemes. Okay, happy working.